The Green Building Components program is based on the relationship between industrial design and architecture, and recognizing that in industry, it's not just about having green design that is passive. It's actually about addressing the components that make up construction and elements of building.
You know, as architects, we can design a single building that is efficient and sustainable, but that's a very small percentage actually of the built environment. Architects are only responsible for about 5% of the buildings that are out there. The potential with these components is to have a much broader reaching effect on the construction industry.
Over the next 30 to 40 years, there's going to be an increase of about 150 billion square feet of construction in the United States. So this is potentially a very large market. And what happens most of the time when there's a renovation is architects go in and they look at the building and they're limited to what they have on, on file or in the product list. And so hopefully this will allow architects to jump in and become a little bit more thoughtful and less wasteful.
One of the things that's really great about this program is that it's positioned in a city that supports that type of thinking, and at a time and it's positioned and set up in such a way that it's actually going in and looking at products, parts, sometimes whole constructs, sometimes one of the other people working on this is doing a window, like just a flashing piece. And having sort of the insight and the strength of character to just look at a flashing piece and not put on your Frank Lloyd Wright hat and like make a 400-foot cantilever, which looks great, but it's not really going to save the world, But that flashing piece could actually have an impact, and I think that what's going on here is unique in that, there's money moving through it, there's a group of people who are willing to think like that, and it could have the potential to really change things.
I'm working on a curtain wall retrofit, which is the application of exterior shading elements to a facade, but I like to refer to it as ACE, adaptive attachment for existing structures. Well, this is the ACE. This is the attachment system. This is a carriage, or what I call an X-body. It can slide vertically along these two tracks, and it's attached to the front of a mullion system that not only satisfies the need for shading elements, but also satisfies the need for solar panel application, wind paneling, cable rigging, signage if necessary, lighting. It becomes a jack of all trades for a facade.
Something I've called terribly efficient furniture. I'll start calling it TEF. And this table that these models are sitting on, it's actually the latest example of TEF, where the legs are part of a 4x8 sheet of plywood that's cut up by a CNC router, and we got up to about 93% efficiency, and all these pieces that are holding up this tabletop nest into slots and spaces on the underside for shipping and display, and the assembly instructions, and in fact every screw will have its own little place on the underside of the table.
There is no boundary between design and architecture anymore, because we are living in the space, we're interacting with the product, or we are dealing with multimodal design element together. So being in the College of Architecture and having industrial design, we are all talking about people and process and place all together.
In Houston, Texas, we have the largest manufacturing capability of any city in North America. And we have the largest manufacturing workforce. So what we're doing is we're coupling our ability as designers, our ability as in applied research, our ability to come up with ideas for the future. And we're trying to build a structure that allows us to take those ideas into the manufacturing capability of Houston.
The space started as a sales center for a green condominium project that we built last summer. And as we develop it further as a reusable sales center, we realized that it had a potential for different uses. And so basically it's 2 recycled shipping containers that were outfitted with a grid-tied photovoltaic system that generated enough power to power the containers for their use as a sales center. And the next version that we want to bring forward into the market for green building components is an off-grid version with 20 panels that will be Houston's first fully off-grid building in terms of its electrical generation on site.
The project's called Oswall. It's an open source wall. We're interested in how it performs from a local standpoint. Can it stand up? Can it withstand impact? Can it do those types of things? But we're also intrigued with how can this thing be more efficient as far as production, as far as the movement of materials and goods to and from a job site. Mark and I began developing this knuckle that we thought could be sort of a governing, formal, an organizer, but that, you know, in the Northwest we might use 2x4s that are salvaged from job sites. It might be bamboo somewhere else, it might be something somewhere else, so that we could just ship a box of connectors instead of shipping board feet of lumber around.
The Green Building Components Initiative is trying to create relationships with industry, local industry. And we got together with a company called Standard Renewable Energy, who's a large solar provider and installer. And they just, their chief technology officer came over with a box of parts and showed us how solar panels are typically installed. And then he explained the problems with the racking and mounting systems. They're expensive, they're very labor intensive, and within just a couple of hours we said, well, why don't we do it another way? I think for us, seeing it for the first time allowed us to completely rethink it. The PV pod is a wedge-shaped, high-density polyethylene vessel that you fill with water as ballast and mount a solar panel to. The ideal application is an existing flat roof building. The PV pod literally is a pod that has a wide stance. It distributes the weight of the water on the building, and the solar panels, when they're installed, need that ballast. They need that weight to keep from flying off a roof.
The PV pod is simply enabling us to get on the roof faster and get off the roof faster, and at the same time have a lower cost of goods in terms of what we need to pay to get the installation done for our customer. So anything that goes to reducing the cost of solar for our customers helps us grow our business, helps more people take advantage of solar, helps more people reduce the debt load that is effectively a utility bill upon all of us. So anything that we can do in collaboration with our partners to be able to bring cost-effective technologies and drive the cost of solar ownership down, we're all over that.
The mission statement for this grant is really to marry industry and economy and sustainability. One reason it's sort of exciting to me is that it's, you know, in a naked way, it's both capitalistic and environmental, and presumably we'll try to market it as environmental, but as soon as possible, an investor will just be interested because it's going to work.
There is this sense that if you have a really good idea and you have the energy and will to see it through, you can make it happen.
This is truly a win-win proposition. This program has given us the ability to offer design commissions, in effect, to our young, very talented faculty members, and they are just jumping on it. The place is hopping. It's really an exciting initiative.